It sits in the constellation Cygnus the Swan, about 1,400 light-years away.
On a chart, it's nothing special. Just another speck among countless others, until the instruments lock on and
Astronomers point their telescopes, expecting a calm stop.
At first they blamed a glitch, a cable, a bug, anything but the star itself. But no matter how they checked, the same impossible pattern stayed.
Normally, a star's brightness is almost perfectly steady.
when a planet passes in front of a star, it carves tiny, neat dips in the light, regular, repeating, and beautifully predictable.
But this star's light curve is chaos. Huge, irregular plunges with no clear rhythm, like the universe is scribbling instead of writing.
It doesn't look like planets or sunspots or pulsations. It doesn't look like anything in our textbooks. It just looks wrong.
The more they zoomed in, the stranger it became, and one question kept echoing in the room. What could possibly block a star like that?
Word spread fast. Soon, observatories across the globe were aimed at Cygnus, all waiting for that star to misbehave again.
Over days, weeks, and months, it kept dimming in wild, unpredictable ways.
One idea was colossal clouds of dust, clumpy, uneven.
Another theory imagined a wild storm of comets, thousands of icy bodies plunging inward, forming an ever-shifting curtain of rock and ice.
Maybe a world was shattered, ripped apart by its own star, its broken pieces twisting into a...
Each explanation fit one piece of the puzzle, but none of them fit all of it. Every time a model worked, another part of the data rebelled. The mystery escaped the observatories. Online, citizen scientists and data nerds joined in, pulling the star's light curve onto their own screens.
They dug through years of Kepler observations, zooming, smoothing, and filtering, hoping the star's wild flickers would reveal a hidden pattern.
But no matter what they tried, clever algorithms, pattern searches, machine learning, the signal stayed stubbornly messy.
Quietly, the universe had dropped a puzzle in our lap. A single star that wouldn't fit into any of our tidy categories.
And then, like a whispered rumor growing louder, a far more outrageous idea crept into the conversation.
What if we weren't just seeing dust or rubble?
A Dyson-like swarm, for instance, countless machines collecting a star's energy, has long been a...
But most astronomers stayed cautious. Wild ideas are fun, but science demands proof, and the numbers alone... Radio dishes were turned toward the star, listening for any repeating signals.
The result was silence. No beacons, no clear messages, just the same irregular dimming, playing out like a stubborn riddle.
Natural explanations still lead the race. Complex dust, tangled debris, or some combination
Each new study crosses some ideas off the list and highlights others, slowly tightening the net around whatever is really happening there. Dozens of papers, countless simulations, hours of debate, all triggered by tiny variations in a single, distant star's brightness.
Remember, this drama is unfolding 1,400 light-years away. When those photons left the star, our world still lived under kings and cows. Centuries later,
From this tiny planet, we can sense barely noticeable flickers in a distant sun, and then sit here arguing about what they mean.
Contests. Every oddball star like this is a reminder. Our theories are temporary, our models incomplete.
We've already found stars that flash like lighthouses, stars that devour neighbors, stars skirting the edge of black holes.
It's not the brightest, closest, or largest star, but it's become one of the most talked about, purely because it refuses to behave.
Somewhere right now, a teenager is downloading its data, a student is scripting a new model, and a scientist is booking time on a better telescope.
Dust models show promise. Dust that blocks blue light more than red, dust that clumps and thins, but even they don't explain everything.
Some simulations come close, almost matching the dips, but tiny discrepancies remain, like the star is whispering, "You're not quite right yet."
The truth might be messy. Tilted disks, intersecting belts, clumps of dust.
Years pass, data piles up, and still no single answer wins. Instead of giving up,
There's a special thrill in not knowing, in facing a problem where the universe has clearly outsmarted us, at least for now. Kepler was built to hunt for planets, not mysteries like this, yet its unwavering stare helped uncover one of the strangest stars we know.
Data streamed back to Earth in quiet bursts. No drama, no headlines, just columns of numbers that would later shake our understanding. In that stillness, with the world asleep, one person watched the graph draw itself and thought, "This can't be right."
but it was. The star really was dimming that much, that suddenly and that unpredictably. The curve was simply telling the truth.
Emails flew, chats lit up, talks were rewritten overnight. A nameless star had just become a celebrity in the astronomy world.
On stage, a female South Asian scientist showed the curve and asked the question everyone was thinking. If it's not a planet, then what is it?
In science, I don't know isn't defeat. It's an invitation. And this star was a loud, blinking, I don't know.
Outside the conferences, the story hit the public. Videos, articles, and posts trying to explain why this one star was freaking scientists out. Some joked about alien superstructures. Others dived into dust and debris. But everyone agreed on one thing. It was fascinating.
Somewhere, a kid looked up and asked, "Which star is it?" And maybe that tiny question nudged them toward a lifetime of curiosity.
Mysteries like this don't just move science forward, they pull people in, inspiring the next generation of explorers and problem solvers.
New telescopes with sharper eyes and broader vision are being built, ready to stare down puzzles like this with far more detail.
By watching the star in multiple colors at once, we can see dust's fingerprint, because dust doesn't dim every color equally.
If blue light fades more than red, that points to dust. If everything dims equally...
Early clues do point toward dust, but they don't settle every question. The pattern remains more complicated than a single simple answer.
Down here, we're surrounded by our own lights, but far above that...
You, watching this right now, are part of the story. The more people care about mysteries like this, the deeper we're able to dig.
Centuries ago would be stunned.
Once, we simply wrote down where the stars were. Now, we track what they do.
This one stubborn star has earned its place in that record, not for its size or color.
Beneath all that dust and debris, the star itself might be perfectly normal, an ordinary sun wrapped in a very abnormal environment.
That's the art of astronomy, studying places we'll never visit and objects we'll never touch, using only the light they send across the void.
Every flicker is a message.
Somewhere, someone is writing a new algorithm, testing a new model, or searching for patterns no one else has thought to look for yet.
While we live our days and sleep our nights, the star keeps dimming and brightening on its own schedule, utterly indifferent to our confusion.
Whether it's dust, debris, or something we haven't named yet, a real story is unfolding there.
Each band of light tells a slightly different version of the story. Put them together, and we may finally see the full picture we're missing.
Maybe, in the end, the answer will be simple and natural, and we'll look back and think.
Or maybe, just briefly, we'll glimpse something we never imagined, forcing us to rewrite what we thought was possible in the cosmos.
In a universe this vast, it might be stranger if everything behaved exactly the way we expect it to.
Just as a heartbeat reveals the health of a person, a light curve reveals the life of...
Somewhere in that patch of sky, a distant sun is flickering in a strange, stubborn pattern, and we're still trying to understand why.
We've discovered millions of stars, but this one is different. Is it dust, debris, or something entirely